Hi everyone, so today we're going to be talking about series and sigmoid notation. But before that we need to know a bit about recursive sequences. And basically what a recursive sequence is that it uses the previous term to find the next term. And so, for example, if you have 1, 3, 5, 7, you just add 2 on from the previous term. So you need the previous term to find the next term. And a really common notation for recursive sequences is using UN. So UN is basically the nth term, or whatever term you're going to be trying to find. So U1 would be the first term. If UN is a term, then UN minus 1 is the previous term. So that's just some common terminology. And so if you have a notation that is UN is equal to 3 UN minus 1, it just means the next term, or whatever term you're finding, is 3 times the previous term. Or something like U1 is 2, that means the first term in the sequence is 2. So pretty easy, not too bad. So we can have a practice. So if we were asked to find the first 5 terms for this recursive sequence, and we know that U1 is 1. So obviously the first term would be 1, and then U2, which is the second term, will be -4 times 1. Because the previous term, which is the first term, is 1. So U2 would be -4. And then U3, which is the third term, would be -4 times -4, which would be 16. And then U4 would just be -4 times 16, which is 64, -64. And the last one would just once again be -64 times -4. Which, let me do this really quickly. It's 256. There you have it. Then, or you might get asked to do the opposite, which is to find the formula for like a general term. General term is just basically UN, because that can indicate any term. So if we have -2, -4, -6, -8, then the general formula, I would always start by looking at the first and second term. Actually, you can pick any 2 terms, but I just like to do it that way. So you can see that -4 is -2 minus 2, or it can be times 2. You don't know, so you got to look at the second and the third term. Now, -2 times 4 is -8, but -8 is the fourth term, and -4 minus -2 is -6. So we know it cannot be times 2, but it has to be negative or minus 2. So then we can find the general formula, which is really UN is equal to un minus 1 minus 2. And that's it. Really simple. So then we can finally move on to series. So a series is really the sum of a sequence of terms. And you have two types. So you have what we call a finite series, and you'll have an infinite series. And the only difference is that a finite series will be adding a fixed number of terms. Whereas infinite series will have an infinite number of terms added together. And then you might ask, so how do we find that? We'll talk about it later on. But more importantly, this is what I really wanted to get to today, which is sigma notation. A lot of students struggle with this, but it's really not that bad. And so sigma notation is really how you write a series. And sigma in Greek looks like this. Actually it has a little, but that's optional most of the time. So an example I'll be using is, this is a finite series. And there's different components to it. So I can use purple to indicate this. There's about 4 different components. So we have this section, which is called the general term, which is just like the rule we talked about in the recursive sequences. But what's more important is this section. And so we'll start from the bottom, and the n equals 1. The 1 is called the lower limit. And basically what that means is that it will be the first n value that is substituted into the general term. So the first kind of value we have is going to be 3 times 1 minus 2, which is 1. So that's going to be the first term. And so at the top of this sigma is the upper limit. And basically what that means is we will be going up to n equals 5. So we'll be doing n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. And then we stop there and we just add those results together. So we found out the n equals 1 answer. And the n equals 2 would be 3 times 2 minus 2, which is 4. And n equals 3 would be 7, 10, and 12. And the sigma, this just means the sum. So add all of those together and you should get 34. This is how we work it out by hand though. And a kind of interesting thing is the n here. The n here is called the index. and it represents a variable. And the values of n would just be consecutive integers. So it has to be a whole number, and what number it is depends on what n equals. So integers. Cool. And so yeah, as I said, consecutive n values are substituted into the general term until the upper limit is reached. In this case, it's 5, and that would be the last value substituted. So you do include the upper limit. So this is for a finite series. For infinite series, the upper limit is infinity because you're adding an infinite number of terms. In this case, so in the formula I've written, you're adding up 5 terms. And then, as I said before, infinite series, you're adding up infinite number of terms. So the upper limit would always be infinite, indicated by the symbol. And it can look something like this. So only way you can tell whether this is a finite or infinite series in terms of sigma is you look at the upper limit. There we go. So we will practice. And once again, so if we have four, so to calculate the sum, we need to find the individual terms. So you'll need term number 1, 2, 3, 4. So first term is -1 to the power of 1, which is -1. Times -1 plus 1. So -1 plus 1 is 0. -1 to the power of 1 is 1. And anything times 0 is 0. So the actual answer term in the series is 0. But if it's 2, second term, we have -1 squared to sorry, my bad. Let me retry that. So -1 to the power of 1 is -1, and then 1 plus 1 is 2. Sorry, I don't know why I put a negative, but it would just be -1 times 2, which is -2. Then, actually, I can just write down sequence is -2. The second one would be -1 squared, 2 plus 1. That would be 1 times 3, which is 3. Then -1 cubed is -1, and 3 plus 1 is 4. So -4. And then the fourth term would be -1 to the power of 4 times 4 plus 1, which is 5. And then we add them up to find the sum, which is, so -2 plus 3 is 1. 1 minus 4 is -3. -3 plus 5 is 2. So the answer is 2. And another way they can ask the question is to write out a series in sigma notation. So we can start with easy one like so. So we know they're increasing by times 4. So we know the general term would be 4n. And so we write the n equals 1. Because it's a dot, 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 that means you're going up to infinite. Because it didn't tell you how many terms you're going. So that's the answer. And a more complicated one, or we can do one with fractions. Can be something like this. So every time you are to work out maybe difficult. So we have to look at the differences. So 3 to 4, 4 to 5 is I reckon, you're timesing the top. It goes like this. Because, see, these two terms are the same, these two terms are the same. That's why the formula is n plus 1, because the bottom one is always one more than the top. And so since this would definitely be a finite series because you only have 3 terms. Yeah, so the key thing is really to notice that the bottom is always one more than the top. And the last one is so to find the kind of rule or the general term, the first thing I would notice is that this is a square number. And so this is 7 squared, this is 8 squared, this is 9 squared, and 100 is 10 squared. So each time we're increasing by 1. And then we have the m, and the m is you're just timesing by an extra m every single time. So it'll just be like that. Great. So that's the general term. I would add that one in. Which is, you start from, the key thing to realize is we do not start from n plus 1, n equals 1. But instead we start from n equals 6. And so then if n equals 6, the upper limit 6, 7, 8, 9. 9 would be the upper limit. And that's how you figure it out.